Good morning, children. How you all are? Hope you all fine. Okay, in the previous class we completed exercise 54. Now I'm going to start exercise 55. Let us start the class. Okay, see exercise 55, children. Exercise 55. See the first one. Put a tick mark against the correct answer. Against the correct answer. Here they given some statements for us and they are asking us to write yes or no for that statements. Yes or no for that statements. Okay. See the questions. First one I will tell you. See the first question in that. Are all multiples of 6? Are all multiples of 6? Multiples of 2? That means the question they are asking us, if some numbers are multiples of 6, they are also multiples of 2. Is it true or false they are asking? Is the statement is true or false? That means here 2 is a factor of 6. 2 is a factor of 6. So, if the number is multiple by 6, then it also multiple by 2. Because the divisibility rule of 6 is if it is divisible by 2 and 3, then it is divisible by 6. So, it must be divisible by 2. If a number is divisible by 6 means it must be divisible by 2. Because 2 is a factor of 6. So, it's a right statement, correct statement. Q tick mark it, yes. Are all multiples of 5 multiples of 10? Are all multiples of 5 multiples of 10? That means if some numbers are multiples of 5, then they are also multiples of 10. So here 10 is the multiple of 5, not factor of 5. If it is factor of 5, then it must and should it satisfies that rule. But here 10 is the multiple of 5. So it must be divisible or it doesn't be divisible. We cannot say particularly it is divisible by 10. So it's a false statement. You tick mark it, no. See the third question. Are 11 and 12 are factors of 121. What are factors of 121? 11 11s 125. Here 11 is only the factor of 121. 11 is only factor, but they are saying 12 also factor of 121. So it's a false statement. See the fourth question. Is 193 a prime number? What is the rule of prime number, children? If a number has only two factors, one in itself, then we call it as prime number. Yes or not? But here they are saying 193 is a prime number. That means it should have only two factors, one in itself. It should have only two factors, one in itself. If it has like that only, then it satisfies the given rule. So, here check the divisibility of 2. It is not an even number, so it is doesn't divisible by 2. 3, if it is sum should be divisible by 2. 3, 12 plus 1, 13. It is not divisible by 3. And 4 also, 5 also, 6, 2 and 3, 3 not satisfied, 2 not satisfied, not 11. 11 ones 11, 73. It also doesn't satisfy. Here if you observe this 193 is not a composite number. It is not a composite number. It is a prime number. See the fifth one. Are 51, 53, 57, 55, 57, 59 prime numbers? They are saying that these are all prime numbers. Is it true or false? They are asking. Here, if you observe these numbers, here some composite numbers are given. What are those? 51 is a composite number, 55 is a are not prime. These are not prime. So you cannot say these are all prime numbers. So it's a false statement. It's a false statement. Okay, children, see the next one, ma. See the first question, sixth one. Write first four multiples of 16. Write the first four multiples of 16. That means you have to write the multiples of 16. First four multiples of 16. What are multiples of 16, children? 16 1 16, 16 2 32, 16 3 is 48, 16 4 64, 16 5 is 80 like that. But here they are asking us to write only the first four multiples of 16. 16 ones, 16 twos, 16 threes and 16 fours you have to write. What are the answers you have to write in the blank? What is 16 ones? 16, 16 twos, 32, 16 threes, 48, 16 fours, 64. These are all the factors of 16. See the seventh one, children. Write lowest missing numeral. Write lowest missing numeral so that the number is divisible by 3. So they given one number 7 3 blank 4 and here they are saying this number should be divisible by 3 means it should satisfy the rule of divisibility of 3. That means you have to place a numeral here to satisfy that rule. What is the divisibility rule of 3? What is the divisibility rule of 3? By 3. Sum of the digits are divisible by 3. Divisible by 3. If sum of digits are divisible by 3, then the given number is divisible by 3. So what are the sum of the digits? 7 3 blank 4. In that 7 plus 3 plus 4, 14. It is not in 3 table. Which number is in 3 table? Which is nearer to 14? 3 5 15 is nearer to 3 table. So you have to place, you have to add this one. If you add, it becomes 50. Then it is divisible by 3. So you have to place 1 here. You have to place 1 here to satisfy that rule that number is divisible by 3. See the next one, ma. See the 8th one. If 1/9 of a number, if 11 is 1/9 of a number, if 11 is 1/9 of a number, if 11 is 1/9 of a number, the number is, that means they are saying 11 is 1/9 of a number, that is 1/9th part of the number is 11. So what is the total number? 9 into 11. 9 11s 99. Say the 9th one. Using digits 0, 6 and 9. Write the possible 5-digit number. Write the possible 5-digit number. Write the possible 5-digit number. What is 5-digit number? It should have 5 digits now. So it should have, we have to write the greatest possible. Greatest one with these digits, and you have to use each and every digit. You have to use each and every digit at least once. At least once. So you have to use all the digits to write that number. So what are those digits? 0, 6, 9. In that, to write the greatest number, you have one time I am writing 0 to write the greatest number. So it's nothing but 99,660 is that greatest possible number with those digits. 10th one. Write all numbers between 100 and 200, 100 and 200, whose digits add up to 7, whose digits add up to 7, whose digits add up to 7. How many such numbers are there? How many such numbers are there? How many such numbers are there? This is the question. So what are the numbers given, children? The numbers sum should be equal to 7. Those numbers should be between 100 and 200. What type of number? First one, 106. If you see this number, 1 plus 6, 7. 1 plus 6, 7. Next, 1, 1, 5. 1 plus 1, 2, 2 plus 5, 7. The sum should be 7. Like that numbers only you have to choose. Here 1 plus 2, 3, 3 plus 4, 7. Next 133. Next 142, 151, 160. Is there some more numbers? 161 means it exceeds more than 7. Its sum should mean exceeds more than 7. So how many numbers are there like that numbers? 1, 2, 3, 4, 5, 6, 7 numbers are there. 7 numbers. Like that you can write. Okay children, in the next class we will meet you again. Till then, goodbye.